recording. So here with this, we want to solve this system basically first using substitution. I'm probably just going to snowflake it to figure out what my x values are. If we want the y values, we can plug both x's in to go from there. So this problem will be a little longer, be slightly more involved than some of the others we have done, but we have everything we need to do this. So remember, with substitution, since they're both y equals, I can essentially set them equal to each other. So this is going to replace the y in the other equation. So I can say x squared plus 4x minus 12 equals 2x plus 3. That's us doing substitution like we did in the very first marking period. In fact, I think it was around week 2 or 3 of marking period 1 that we did this. So all I'm doing is setting these equal to each other. Now, when we look at this, we solved problems like this in our quadratics unit just a few weeks ago, right? Right before break, we were solving problems like this. So let's go ahead and give this a try. Just want to set a timer so I don't take too long. So first thing I'm going to need to do is I need it equal to 0 because it's a quadratic. So, okay, let's subtract 3 and subtract 2x. In doing so, that gives me x squared plus 2x minus 15 equals 0. Now, I know some of you prefer the quadratic formula. For time's sake, I see I can factor this. I find factoring to be faster when I know I can do it. So I'm going to solve this using factoring. If you want to solve this using the quadratic formula, go ahead, be my guest. You'll get the same answers. You'll still get it right. It's not a big deal. So I'm going to set up my snowflake. Negative 15 in the numerator, 1 and 1 on the sides, 2 on the bottom. So what multiplies to give me 15? We have 1 and 15, right? What else? What multiplies to give me 15? Yeah, 5 times 3. If I do 5 minus 3, that gets me 2, right? So it will be 5 and a negative 3. So I get x plus 5, x minus 3 equals 0. Now I can split them and solve. X plus 5 equals 0. Subtract 5. We get x equals negative 5. Over here, x minus 3 equals 0. Add 3, and we get x equals 3. Now, I know you're going to say, oh, we did all that. That's it, right? There is, remember, one more step. I have both x and y in my system. So I do want the answer for y. So what I'm going to do is I'm going to put both these x values. Now the second equation, it just says 2x plus 3. That looks a lot less complicated than x squared minus, or x squared plus 4x minus 12, right? So let's just plug each of them back into the second equation because it's easier. So I could say y equals 2 times negative 5 plus 3. So that would be y equals negative 10 plus 3. Y is negative 7. So I get the point. Negative 5, negative 7. That's one solution. Going to do the same thing here. Y equals 2 times 3 plus 3. Y equals 6 plus 3. y equals 9. So I also get the point 3, comma 9. I'm going to give you guys about a minute to make sure you got that down. It will be posted. I'm also going to show us how we can do this on Desmos. Because if I recall correctly, the problem that's like this on the final, I think is a multiple choice question. So I'm going to also show you how you can just graph both these equations and click on where they cross. This is the formal math. This is, again, we didn't solve problems like this semester, but we did all these skills. It was just a matter of bringing them together. Let's take a look at graphing this. If I graph this, there's Desmos, y equals x squared plus 4x minus 12. And I also have y equals 2x plus 3. So when I graph it, I see, well, let's zoom out. Oh, there we go. I was zoomed pretty far in. I see they cross right here. Hey, -5, -7. And they cross up here, 3, comma 9. So let me go projector. No, well, I'll do that anyways. Projector mode. It's a little bigger for you guys to see. So again, I click on where they cross, and those are the same two answers we just got. -5, -7, and 3, comma 9. So our math lines up with the graph. Any questions on number 11 right now? I know the work was a little much. That's why I'm showing you this backup way of saying, well, look, I know on the final it's just multiple choice. You can just look at the graph and tell me where they cross. It will be good. Okay, let's move on. That was number 11. Let's look at number 13. So number 13, my goal is to find this right here. I want arc AB. I know that this is 110, this is 72. So now it's just a matter of trying to piece together all my information. I'm going to highlight this in blue. Let's take a look and see what we know. What can you tell me about the arc I just highlighted in blue? What piece of information can we figure out off of this arc? What do we know about this arc? Even if it seems like a very simple observation, just let me know. It's half the circle. That's a simple observation, but yeah, it's half the circle. So it's all three of these sections have to add up to 180, right? Well, I know this is 72, but unfortunately, I don't know the other two. However, I'm going to now look at this in purple. How much is this purple section? That's another 180. But this one's only broken into two sections, right? One I know is 110, and the other I don't know. So based off of that, I could say, wait, this right here is 180 minus 110, right? Let's do that, 180. Let me write that. So right here, I'm doing 180 minus 110, and that's equal to 70. So I know that that angle's 70. Now I know two of the three sections here, right? So since the blue has to add up to 180 to get the red, I can do 180 minus 72 minus 70. So just for quick time's sake, I'm just going to do that in the calculator. 180 minus 72 minus 70. And we get that that last angle is 38 degrees. Now, one thing I know you may say here is, well, Isakov, does that really look like 38 degrees compared to these other ones? Maybe. I don't know. Kind of looks like it might be maybe a little bigger than that. It looks a little closer in size to that. This is just a rough sketch. I did things very deliberately, made things look very nice, but I don't think I actually formally measured things here. I just drew a nice picture and added the numbers in. So the size of the angles may not be 100% accurate in comparison to what they actually are on the paper. They may be close, but I don't think I measured them out to be 100% accurate. So that's a circle problem. I know the circles, they were a little trickier. I don't think there are too many circle questions on the final, but yeah, there is that. Any questions on that one? Okay. Looking at the time, I have time to go over one more with you guys. We'll go over 15, where we're just finding the equation of this graph. So first it asks what's the roots, and then what's the equation? So first I want to know where it crosses the x-axis. It crosses at -3, so this point's -3, 0. And then this point over here is 2, 0. Now, if you recall, when we were factoring and solving, if I had like an x -2, when I solve that, that gives me a positive, x equals +2. So please remember, we do the opposite of these. Looking at grading the quadratic quizzes from before break, those of you that remembered how to do this problem, that was our biggest mistake. You would identify the zeros, and then you kept them exactly the same. We need to do the opposites here. So I'm going to have it be x +3 and then x -2. Now I'm just going to FOIL this out. I know some of you have dropped the FOIL structure, and that is perfectly okay. Some of you still use FOIL and write it out, and that's okay too. I'm going to write it out this way just for those that are still needing a little more structure to it. So x times x, x squared. My outers, x times -2, -2x. My inners, 3 times x, it's a +3x. And then finally, my last, 3 times -2 is -6. Combine my outer and inner. So these are like terms, they'll get combined here. So it comes x squared, -2 + 3 is a +1x -6. And that's it. So again, didn't want to take too much of our time. I want to give you all the time I can to work on this. Please make sure you are giving this a try and asking questions if you have them. I am here to help. Let's stop the recording. Yes.